that is this block diagram reduction. So I think you can check the block diagram that is given here. The question is find transfer function by block reduction. I think it is visible to you, so I'll be explaining this. What we have done in module 1 is we have seen what are the advantages of transfer function based modeling. Now here I am giving you one case where there are 4 forward path gain, that is G1, G2, G3, G4. They are connected in a certain fashion, and there are 3 feedback paths. So feedback paths are, one is H1, sorry, this G4 is actually not feedback, this G4 the forward, this is a feedback path. So there are 3 feedback paths and 3 forward gains. So G1, G2, G3, they are forward gains. Okay, and feedback gains are given by G4. So generally feedback gain is given by H, but here it's given by G4, does not matter, it's just a name. And here it is H1, and this is another feedback path. So just see the arrow direction. Whenever arrow is from outside to the input side, this is a feedback path. H1 is also arrow from after G2 and it is coming back to the initial summing point. And this G4 is also a feedback path because this is starting from output and coming back between G1 and G2. So there are 3 feedback paths, H1, G4, and this feedback path is not given any gain. So if there is no gain given in any path, we have to assume that the gain is equal to 1. So this is the scenario. Now we are supposed to find out what is the transfer function of the system. Now output is given by CS, input is given by RS. Actually this G1, G2, G3 all are G1S, G2S, G3S, G4S, H1S accordingly. So we have not mentioned S here, so that's why this is G1, G2 and G3. Now what is the most problematic point? So there are 2 summing points. This is the summing point 1 CS1, this is summing point 2 CS2. So in more complex numericals where you can exchange summing points, what you can name is, you can name this as CS1 and you can name as CS2. But here this is not a very complex problem, but yes, there is a certain amount of complexity in it. And what is the main difficulty in any block diagram reduction that we are supposed to understand. So you can see that the main difficulty is this feedback path H1. Okay, and all the feedbacks are negative feedbacks because this H1 is coming in minus. This feedback path with gain 1 is also minus, and this G4 is also minus. So all these 3 feedbacks are negative feedbacks. So what is the main problematic part in this? Main problematic part is this feedback path H1, or rather we will call it minus H1. Okay. So what is the problem? Problem is this is in between G2 and G3. So we can solve the whole numerical if this H1 is solved somewhere. Now we can shift H1 in the left, we can shift H1 in the right. So what is the solution here? Take the feedback point after G2 to the right, after G3. So this point have been shifted right. So in the next in the next diagram, so this kind of diagram you are expected to draw during examinations, because if you are not drawing diagram, then it is difficult for the examiner to understand exactly what's happening. So this is the first diagram. In the first diagram, what we are doing is we are shifting this point H1 to the right side. So if you are shifting the point to the right side, at that time what happens is, previously this H1 was there just after G2. Now as you are shifting this point to the right, that means previously whatever feedback you were taking, the G3 component was not there. Now as you are taking it to the right, so this forward path is getting multiplied with G3 and then it is being fed back. Hence this H1 is to be modified with H1 by G3. So in very simple way we say that if the feedback path, if the feedback point is taken right to the any block, that block has to be divided and adjusted in the gain. So that's why whenever we are shifting this point to the right, what we have done is this H1 has become H1 by G3. This is the only adjustment we have to do. No adjustment in G4, so G4 in this diagram and G4 in this diagram is same. No adjustment is this 1, so this 1 is also like this. Now this has become a very simple kind of loop. So there are 3 feedback paths, and the top one is called as feedback path 1 with gain minus G4. This second one has become minus H1 by G3 and third one has become minus 1. So this is the only adjustment, that is this H1 has to be taken to the right. If you are taking that, then all the thing becomes very easy. What is next? Now we have to check from the second diagram. So G2 and G3, they are in cascade. So G2 and G3, they become G2, G3. Okay, and this loop we will solve first. So we know that whenever G and H, they are forming a closed loop with negative feedback, the overall transfer function is G divided by 1 plus GH. Now here forward gain is G2 G3, feedback gain is G4. That's why this part becomes G2 G3 divided by 1 plus G2 G3 G4. So whatever is this top block, it has become G2 G3 divided by 1 plus G2 G3 G4, and this G1 will remain as it is. So now this summing point 2 has been actually converted into this G2 G3 by 1 plus G2 G3 G4, and this G1 now will get multiplied with the next one. So G1 and this whole combination now is in cascade. So in the next part, what we have seen is G1 and G2 G3 divided by 1 plus G2 G3 G4. This H1 has become H1 by G3, feedback path 2, it stays here, and there's a feedback path 3, it stays here as 1, or rather it is negative feedback, so it can be called as minus 1. I'll go to the next slide. It says that now you can check that G1 we have included in this G2 G3, so the top forward path has become G1 G2 G3 divided by 1 plus G2 G3 G4. So now there are only two feedback paths, one is H1 G3, and the bottom part, it was, if you are not writing anything, automatically it becomes 1. So now step by step we can solve this. So now let us take this inner loop first. So forward gain is G1 G2 G3 by 1 plus G2 G3 G4, feedback gain is H1 by G3. If you are trying to find what is the overall loop gain for the closed loop path with negative feedback, so this is G divided by 1 plus GH. Now in case of this, forward gain is G1 G2 G3 by 1 plus G2 G3 G4, and 1 plus the whole thing multiplied by H1 by G3. So this G3 and G3 gets cancelled. Okay, so this becomes H1 G1 G2. So if you are solving this part here, so this becomes G1 G2 G3 divided by 1 plus G2 G3 G4 plus G1 G2 H1. So now this is actually the overall transfer function of this inner loop. Okay. Now this inner loop is having overall transfer function of G1 G2 G3 1 plus G2 G3 G4 G1 G2 H1. This I have written here, and whatever is the feedback path, that feedback path is actually having a feedback gain of 1. It is like this. Okay. So now what we find is the whole thing is again creating a feedback loop and with negative feedback, and that if you are trying to find G and H, what you will be find is this G divided by 1 plus GH. So G is now G1 G2 G3 plus 1 plus G2 G3 G4 plus G1 G2 H1 divided by 1 plus the whole thing multiplied by 1. Now if you are simplifying it, it becomes final answer CS by RS G1 G2 G3 divided by 1 plus G2 G3 G4 plus G1 G2 H1 plus G1 G2 G3. So this is the final answer. What I'll do is I'll go to the next block, previous diagram. I'll give you 5 minutes. Please copy this page at least. Please write these 3 things at least. So I'm giving you 5 minutes time. Please write these things. Okay. So now this is 10:15. I'm giving you rather 3 minutes time. Copy this numerical and this first 3 steps. This will be for your practice.